This week began with a holiday here in the U.S. We have President's Day, and so on Monday of this week, and so I was able to spend. I had family time. Of course, it's a holiday for us, but I also spent, I think, about 5 hours reading, and that was really, really good. As far as problems are concerned, I've started plowing through Chapter 6, and Chapter 6 has been straightforward. I don't want to use the word easy because there are many difficult problems throughout this book in every chapter. But yeah, I've been able to work through some of the basic problems in section 6.1, 6.2, and 6.3 with some effort, but yeah, I'm making progress. No doubt I'm making progress. I'm looking forward to finishing. I think if at the pace that I'm going, I should be able to finish chapter 6 next week for problems. Now, for reading, I was able to finish all of chapter 7, and I've started on chapter 8 and read section 8.1, and now I'm reading section 8.2, and I also read Appendix C on linear algebra. But going back to Taylor's equation in section 7.4, analytic functions, I wanted to understand how this equation is derived in gory detail, even much higher detail than it's shown here. And so I went through, and I'm going to link it. I'm going to find the link. Somebody, I believe he's from the UK from his accent, I'm not sure, did a great series of videos, and he does it in a sequence that worked perfect for me. And let me see if I can find Rolle's theorem. Well, so he starts with Rolle's theorem, which has, of course, 2 points. He does them where the 2 points are on the y-axis, and then there's a maximum. Of course, and there's a zero derivative at some point. He uses Rolle's theorem, of course, to prove mean value theorem, which is the way Wade does it. But then he extends it to the extended mean value theorem, ending in Taylor's equation. So that was pretty good. I think I spent a good 2.5 hours just on that out of the 5 hours. I wanted to do that. I think when it comes to some major theorems, I like to take my time. For problems, did some problems for section 6.1, 2, and 3. I'll show them. Yeah, and I want to be able to finish chapter 6 and start on chapter 7 problems next week. For my schedule, this is week number 9. I started numbering these, so I'm on week number 9. I'm still a good month ahead in the reading, and I want to continue doing that. If I can do that all the way to the end, then I can have like a whole month just of problems, where I go back and solve more problems. I'm not sure. Maybe I'll do some topology. I'm still unsure how I'm going to fill the schedule hole between finishing Wade and taking a class, which would begin somewhere in August. To be determined. Still, as of now, making a lot of progress. Of course, section 7.4 was really long, just because I wanted to truly understand how Taylor's theorem is derived. So I think on section 7.4 alone, I think I have probably spent 10 hours just reading. But, you know, it's worth it. It has to be done. It has to be done that way. I don't want to just transcribe content from a book. That is not what I am here to do, folks. Then that's my marker for where I was last time. And so I found another handout, trying to limit the handouts, but I'm finding with advanced calculus, real analysis, where all those courses in various universities intersect, there is such a wealth of great content out there, and I want to keep it somewhere, so the best place is to put it in this notebook. Yeah, so problems, section 6.1, then section 6.2, and then section 6.3, which is what I'm working through now. Yeah, just working through some problems. You know, and some, it looks like I'm a little lost, but I sort of know what I need to prove. And for example, in this problem, I know that it converges. I know that the terms have to cancel somehow. and the number does not grow infinite. I know that, but I need to show it. So that's where the trick comes in. And then, of course, then I'll eventually load these notes to the notebook. But this is all of Chapter 7 with yet another little handout in here for finding radius of convergence. I want to practice some of those problems. But yeah, Chapter 7 reading was massive. Just massive. And I'll show these notes once I finish Chapter 6 notes. So that's all we have for this week.